Hello everyone, this is Dr. P. Srilatha, Associate Professor of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about problems on Bayes theorem. Before going to start problems, first we will discuss about Bayes theorem statement. So what is Bayes theorem statement? So what is Bayes theorem statement? If E1, E2, E3 and so on En are mutually exclusive events and A is any arbitrary event, then probability of Ei divides A equal to probability of A divides Ei into P of Ei divided by summation I equal to 1 to n probability of A divides Ei into P of Ei. So here, this is our sample space. So this is arbitrary event A and this is E1, this is E2 and this is E3 and so on. This is En. Okay. So here E1, E2, E3 and so on En are mutually exclusive events and A is any arbitrary constant. Then the Bayes theorem is P of probability of Ei divides A equal to probability of A divides A into P of Ei divided by summation I equal to 1 to n probability of A divides Ei into P of Ei. So note, already we have discussed one problem previous session. Okay. So based on that problem, here we have written one note. So what is that note? So probability of E2 divides A. P of E2 divides A means getting white ball which is coming from bag 2. And P of A divides E2 means selecting bag 2 and then getting white ball. So that is probability of A divides E2. So first problem, bag 1 contains 2 white, 3 red balls. And bag 2 contains 4 white, 5 red balls. One ball is drawn at random. From one of the bag, it is found to be red. Find the probability that red ball is drawn from bag 1. So here we have 2 bags. So first one is bag 1 and second one is bag 2. So in bag 1, we have 2 white balls and 3 red balls. In bag 2, 4 white balls and 5 red balls. Okay. So here, let us consider bag 1 is E1 and bag 2 is E2. So bag 1 is E1 and bag 2 is E2. Now find the probabilities for E1 and E2. So probability of E1 equal to, by the definition of probability, what is the probability of E? That is m by n. Favorable events divided by total number of events. So here favorable events are only for E1 only 1. Out of how many bags are there? 2 bags are there. So total number of events are here 2. The favorable event is for E1 we are finding no. So that's why the favorable event is 1. So P of E1 equal to 1 by 2. So like that, probability of E2 equal to, here also same, here favorable event for bag 2 is 1 and the total number of events are here 2. So that's why that is 1 by 2. So probability of E1 is 1 by 2 and probability of E2 is also 1 by 2. And A. So what is A here? One ball is drawn at random from one of the bag. It is found to be red. So let us consider event A equal to one ball is drawn at random from one of the bag. It should be red. Okay. So in bag 1 we have, in bag 2 in bag 1 we have 2 white, 3 red. So 2 white, 3 red balls. In bag 2 we have 4 white, 5 red. 4 white, 5 red balls. Okay. So here we are choosing only red balls. So we have to focus on only red balls. Okay. So probability of A divides even. So we have to choose red ball from bag 1. We have to choose red ball from bag 1. So that is probability of A divides even. Probability of A divides even equal to. So how many red balls are there in bag 1? So here we have only 3 red balls. So that means 3C1 divided by how many balls are there? 5 balls. So 5C1. That means 3 by 5. Okay. So probability of A divides even. We have to choose red ball from even is bag 1, right? So like that we have to find probability of A divides E2. So probability of A divides E2. So that is, so in how many? E2 is nothing but here bag 2. So in bag 2, how many red balls are there? So here we have 5 red balls are there. So that's why 5C1 divided by total number of balls are 9. So 9C1. So that means 5 by 9. So that means 5 by 9. Probability of A divides E2 is 5 by 9. So we have to focus on only red balls. Okay. So now, so what is the main question? Find the probability that the red ball is drawn from bag 1. So the red ball should be, the probability of red ball should be drawn from bag 1. So that means, so what we have to find here? So we should focus on bag 1. So that is bag 1. We have to choose bag 1 first, then we have to focus on red ball. So that is, what is our, by the Bayes theorem, what is our formula? So what is our formula for Bayes theorem? Probability of EI divides A equal to probability of A divides EI into P of EI divided by summation I equal to 1 to n probability of A divides EI into P of EI. So here, so we should focus on only bag 1. So that's why we should focus on only bag 1. So that's why we need to find even. So our bag 1 is even here. Even divides A equal to probability of A divides even into P of even divided by how many bags are there? I equal to 1 to 2 bags are there. So that's why probability of A divides EI into P of EI. So expand this one. Probability of A divides even into probability of even divided by P of A divides even. First we have to substitute I equal to 1 here. Probability of A divides even into P of even plus probability of A divides E2 into P of E2. So probability of even divides A equal to probability of A divides even into P of even divided by probability of A divides even into P of even plus probability of A divides E2 into P of E2. So here we have to substitute all those values here. So what is probability of A divides even? Probability of A divides even is 3 by 5. Already we have solved. Probability of A divides even is 3 by 5. Probability of A divides E2 is 5 by 9. So here probability of A divides even is 3 by 5 into P of even. So here already we have found P of even is 1 by 2 and P of E2 is 1 by 2. So from that probability of A divides even is 3 by 5 and P of even is 1 by 2. So probability of A divides even is 3 by 5 and P of even is 1 by 2 plus probability of A divides E2 is 5 by 9 and P of even is 1 by 2. So if you solve this one, you will get the answer. So that is, what is our question? The probability that red ball is drawn from bag 1. Red ball is drawn from bag 1. So here bag 1 is denoted with E1 and bag 2 is denoted with E2. Okay. So like that we can solve. So like that one more problem is there. So that is in a certain college 25% are boys, 10% are girls are studying mathematics. The girls constitute 60% of classroom. First question. What is the probability that mathematics is being studied? Second one. If a student is selected at random and is found to be studying mathematics, find the probability that the student is a girl. So here let us consider girls are E1 and boys are E2. So let us consider girls are E1 and boys are E2. So girls are E1 and boys are E2. And boys are E2. So like that, or you can take boys are E1 and girls are E2. So how many girls are there? So here the girls constitute 60% of classroom. So girls constitute of 60% of classroom. So remaining are boys, right? So remaining are, how many remaining are there? Here 40% of boys are there. Okay. So what is probability of E1? P of E1 equal to 60% and P of E2 equal to 40%, right? So P of E1 equal to 60%. 60% means 60 by 100. So that is 0.6. Like that, probability of E2 equal to, probability of E2 means probability of boys. So that is 40%. That means 40 by 100. That is equal to 0.4. So let us consider A is an event of studying mathematics. A is an event of studying mathematics. Okay. So for girls, we need to find for girls event of mathematics for girls and for boys. We need to find event of mathematics for girls and for boys. So how many are there? So the girls, 10% of girls studying mathematics. 10% of girls are studying mathematics. So that's why probability of A divides E1. So here E1 is denoted with, E1 is girls and A is studying mathematics. So how many girls are studying mathematics? How many girls are studying mathematics means, so here 10% of girls are studying mathematics. So that's why 10 by 100. So next we need to find how many boys. So E2 means boys. How many boys are studying mathematics? Studying mathematics. How many boys are studying mathematics? Here 25% are studying mathematics. So that means this is 25%. So 25% means 25 by 100. So that is equal to 0.25. 25 by 100. P of A divides E2 equal to 25%, and that is 25 by 100, that is equal to 0.25. So P of A divides E1 is 0.1. So what is our first question? So what is our first question? What is the probability that mathematics is being studied? The probability of mathematics is being studied. That means we need to find P of A. Probability of A equal to, we have formula. So what is that formula? Probability of A divides E1 into P of E1 plus probability of A divides E2 into P of E2. Already we know that probability of E1, P of E1 equal to 61 plus 0.6 and probability of E2 is 0.4. So probability of E1 is 0.6 and probability of E2 is 0.4. Probability of A divides E1 is 0.1 and probability of A divides E2 is 0.25. So substitute all these values here. Probability of A divides E1 is 0.1 and probability of E1 is 0.6 plus probability of A divides E2 is 0.25 and probability of E2 is 0.4. So if you simplify this one, you will get 0.3 0.07. So this is the answer. So that is the probability of mathematics is being studied, that is equal to 0.07. So next, what is our question? Second question is, if a student is selected at random and is found to be studying mathematics, find the probability that the student is a girl. Find the probability. The probability that the student is a girl studying mathematics. That means girl. We know that girl is denoted with E1 and boy is denoted with E2. So here we need to find E1. So that means probability of E1 divides A equal to probability of A divides E1. By the statement of binomial, we need to write probability of E1 divides A. For girls, we are writing. So, probability of E1 divides A equal to probability of A divides E1 into P of E1 divided by how many students are there here? Boys and girls, both, right? So, I equal to 1 to 2. Probability of A divides EI into P of EI. So, this is our Bayes theorem statement formula. So, Bayes theorem formula. Right? So, here we are going to find E1. E1 is girls and A is studying mathematics. How many girls are studying mathematics? That means probability of E1 divides A equal to probability of A divides E1 into P of E1. Probability of A divides E1 into P of E1 divided by summation I equal to 1 to n probability of A divides E1 into EI into P of EI. So here substitute I equal to 1 and I equal to 2 here. We will get probability of A divides E1 into P of E1 plus probability of A divides E2 into P of E2. So, but we know that probability of E1 is 0.6 and probability of E2 is 0.4. So, like that probability of A divides E1 is 0.6 and probability of A divides E2 is 0.25. Substitute all these values here. So, probability of A divides E1 is 0.1. Probability of E1 is 0.6. Okay, so probability of A divides E1 is 0.6, 0.1 and probability of E1 is 0.6 and probability of A divides E2 is 0.25 and probability of E2 is 0.4. So, substitute all these values here and after simplifying you will get 6/7. So, that is the answer for the probability of the student is a girl which is who is studying mathematics. Next question. In a factory, machine A produces 40% of output and machine B produces 60%. On the average, 9 items in 1000 produced by A are defective and 1 item in 250 produced by B is defective. An item drawn at random from a day's output is defective. What is the probability that it was produced by A or B? So, it is produced by A or B. So, let us consider machine A is E1 and machine B is E2. So, now let us consider machine A is E1 and machine B is E2. So, now we have to find the probabilities for E1 and E2. So, probability of E1 is machine A produces 40% and machine B produces 60%. So, that's why probability of E1 equal to 40%. 40% means 40 by 100. So, that is equal to 0.4. So, like that, probability of E2 equal to 60%. That means 60 by 100. That is equal to 0.6. So, now, what is A? So, A is, let us consider A is defective item. Let us consider A is defective item. A be the event of selecting defective items. So, we have to select from machine A. We have to select a defective item from machine A. So, machine A, from machine A, that is 9 items in 1000. So that means probability of A divides E1 equal to, so E1 is mission A. E1 is mission A. So that's why probability of A divides E1. A is defective item. So probability of A divides E1 equal to, that is 9 by 1000. So like that, we need to find for mission B, defective item for mission B. Defective item for mission B is probability of A divides E2. So that is equal to 1 by 250. 1 by 250. So like that, probability of A divides E1 is 9 by 1000 and probability of A divides E2. So we have to select mission B. From mission B, we have to select defective item. So mission A, we have to select defective item. So probability of A divides E1 is 9 by 1000 and probability of A divides E2 is 1 by 250. 1 by 250. So now we have to calculate what is the probability that it is produced by A or B. So that means here we need to find probability of A. A is nothing but mission A is E1 and mission B is E2. So we need to find E1 divides A. That means we have to find the defective items from E1 and defective item for E2. So that is we need to find, by Bayes theorem, we need to find probability of E1 divides A and also we need to find probability of E2 divides A. Okay, so probability of E1 divides A equal to, by the Bayes theorem, A divides E1 into P of E1 divided by summation I equal to 1 to n, probability of A divides E1 into P of E1. So this is our Bayes theorem formula. So for that, probability of E1 divides A equal to probability of A divides E1 into P of E1 divided by summation I equal to 1 to how many missions are there here? 2 missions are there. So that's why we have to substitute I equal to 1 and I equal to 2 also. So for that, probability of A divides E1 into P of E1 plus probability of A divides E2 into P of E2. So we know that P of E1 is 0.4 and P of E2 is 0.6 and probability of A divides E1 is 9 by 1000 and probability of A divides E2 is 1 by 250. So substitute all these values here. Probability of A divides E1. So that is 9 by 1000. Probability of E1, that is 0.4. Probability of A divides E1, that is 9 by 1000. Probability of E1, that is 0.4 plus probability of A divides E2. So probability of A divides E2 is 1 by 250 and probability of E2 is 0.6. Okay, so substitute all those values in Bayes theorem formula, you will get the answer. Okay, simplify this one, you will get the answer. So next one we need to find. So here they have given that what is the probability that it was produced by A or B. We need to find both A and B. So for that, probability of, by the statement of binomial, probability of we need to find for mission B. Mission B is nothing but E2. Okay, so probability of E2 divides A equal to probability of A divides E2 into P of E2 divided by summation I equal to how many missions are there? 2 missions. So probability of A divides EI into P of EI. So here substitute I equal to 1 and also substitute I equal to 2 here. Okay, so from that you will get the formula. So that is probability of E2 divides A equal to probability of A divides E2 into P of E2 divided by probability of A divides E1 into P of E1 plus probability of A divides E2 into P of E2. So we know that probability of A divides E2, probability of A divides E2 is 1 by 250. 1 by 250 and probability of E2 is 0.6. Probability of E2 is 0.6 and probability of E1 is 0.4 and probability of A divides E1 is 9 by 1000. Probability of A divides E1 is 9 by 1000 and probability of E1 is 0.4. So probability of A divides E2 already we have written here, that is 1 by 250 into probability of A divides probability of E2. So probability of E2 is 0.6. So substitute all these values and simplify, you will get the answer. So next question, suppose 5 men out of 100, 25 women out of 10,000 are color blind. So I think all of you know that. Let us consider A be the event of color blind. A be the event of color blind. So what about E1 and E2? Let us consider men is E1 and woman is E2. Let us consider here men is E1 and woman is E2. Okay. So from that, so find the probabilities for E1 and E2. How many members are there here? 2. Men, 2. 2 possibilities are there. So total number of events are, for E1, total number of events are 2. In that favorable event is only men is there. So that is 1. So 1 by 2. So like that, probability of E2. So that is total number of events are men, women. 2 possibilities are there. So that is 2. From that, we need only women. So that's why probability of favorable events are 1. So that's why that is probability of E2 equal to favorable events divided by total number of events. P of E2 equal to 1 by 2. Like that P of E1 is also 1 by 2. And we know that, let us consider event A is color blind. So event A is our color blind person. So from that, we need to find for men and women. So for men, what are the possibilities there? So for men, that is probability of A divides E1. Probability of A divides E1 is 5 by 100. So like that, probability of A divides E2 equal to 25 by 10,000. Probability of A divides E1 is 5 by 100 and probability of A divides E2 is 25 by 10,000. So what is our question? So here our question is, what is the probability that the color blind person is a man? So therefore, the probability of color blind person is a man. Color blind person is a man. So that means here we need to find the probability of color blind person is a man. So for that, so man is, we know that man is denoted with E1, right? So that's why we need to find probability of E1. E1 is a man. Here E1 is, man is denoted with E1. So E1 divides A equal to probability of A divides E1 into P of E1 divided by summation. How many possibilities are there? Men, women. So probability of A divides EI into P of EI. So if you expand this one, we will get the formula. So probability of E1 divides A equal to probability of A divides E1 into P of E1 divided by probability of A divides EI into E1 into P of E1 plus probability of A divides E2 into P of E2. So we know that probability of E1 is 1 by 2, probability of E2 is 1 by 2. So P of A divides E1 is 5 by 100 and probability of A divides E2 is 25 by 10,000. So substitute all those values here. So probability of A divides E1 is 5 by 100 and P of E1 is 1 by 2. Probability of A divides E1 is, already we have written here, that is 5 by 100 and P of E1 is 1 by 2 plus probability of A divides E2 is 25 by 10,000 into probability of E2 is 1 by 2. So substitute all these values here, you will get the, after simplifying, you will get the answer. Okay. So now exercise problems. Bag A contains, first question is, a bag A contains 3 blue, 4 green balls. And bag B contains 5 blue and 6 green balls. One ball is selected at random from one of the bag and it is found to be green ball. Find the probability that the green ball is drawn from bag 3. So here we have two bags, that is bag A and bag B. Okay, so let us consider this is event E1 and this is event E2. Okay, so what is A? So A be the event of selecting green ball. A be the event of selecting green ball. So here, so what is probability of E1? So probability of E1 is 1 by 2 and probability of E2 is also 1 by 2. I think all of you know that here we have two bags. From that we have to select one bag. Okay, so that's why P of E1 is 1 by 2 and P of E2 is 1 by 2. So let us consider A is the event of selecting green ball. A be the event of selecting green ball. So for that we need to find probability of A divides E1 equal to. So here we have to select only green ball. So how many green balls are there in bag 1? E1 is nothing but bag 1, right? So from that, for that we need to select green ball only. So how many green balls are there? 4 green balls are there. Divided by total number of balls are 7. So like that we need to find probability of E2. So how many in bag 2? E2 is nothing but bag 2. So this is bag 2 is E2. So here also we need to focus on green balls. How many green balls are there? 6 green balls are there out of 11. Out of 11 green balls. So that's why probability of A divides E2 is 6 by 11. So now what we need to find? So here we are going to find the probability that green ball is drawn from bag 2. So that means, so here we need to find probability of bag 2 is right here E2. So probability of E2 divides A equal to probability of A divides E2 into P of E2 divided by, so summation I equal to 1 to 2 probability of A divides EI into P of EI. Okay, so like that we have one more problem. So that is there are 3 boxes. First box contains 3 white, 4 green and 2 yellow balls. Second box contains 2 white, 3 green and 4 yellow balls. Third box contains 5 white, 2 green and 3 yellow balls. One ball is selected at random from one of the boxes and it is found to be yellow. If the ball is yellow, find the probability that it is from third box. So that means here we need to find E3 divides A. So here we have to choose third box only. This is also same procedure. So but here we have 3 boxes. So that's why. So P of E1 is 1 by 3. P of E2 is also 1 by 3. P of E3 is also 1 by 3. Because here we have 3 boxes are there. Okay, so here we need to find, we have to choose only yellow ball. So let A be the event of selecting yellow ball. Let A be the event of selecting yellow ball. So same procedure we have to find the problem. Okay, so here also we need to find probability of A divides E1, probability of A divides E2 and probability of A divides E3. Finally, we need to find probability of E3 divides A. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.